So going back for a while to lesson 6-2, this is the concept summary, and we can see that if the number we decide we are multiplying by is greater than 1, my numbers will be increasing. So that means the graph from left to right will go up. Whereas if that number in parentheses, the number that we are raising to the x power, in other words, the b right here, if it is between 0 and 1, then my numbers will decrease. So they will go down each time. And that forces the graph to go down from left to right. So let's keep that in mind, and let's get now here to this example. It says the population of a city grows at an annual rate of 15%. What will the estimated population of that city in 5 years? So it's going up, it's increasing. Grows is a word for increasing. So we can model this with an exponential function, but of course that number b will have to be greater than 1 because that's what it says here, it grows. So that r right here is the percentage that is increasing. So in this case, we know the percentage of increase is 15%, and we also know that 15% as a decimal. So when we do 15 divided by 100, we actually get that. We'll try to put it here. So this 15%, a little reminder, this is the same as 15 divided by 100. And when you do 15 divided by 100, you get 0.15. So this is just that same percentage that you see the population is increasing, only it is written as a decimal. Okay, so it's not written now no anymore with the percentage symbol, but as a decimal. So you see, so now once we determine what, this is the initial population, so the current population, and when you add those two numbers, you get a number that is greater than 1. So only now we can see that models the example because that number b is greater than 1. And step number 2, if we want to calculate the population after 5 years, all we gotta do is to replace the value of x. So that means we are replacing this by 5. We'll use our calculator and we'll get our answer. So this is how many people will have in 5 years, will be there in 5 years. All right, so that is example 1. Now we want to go quickly to example 3 because that is going to be kind of the example about not increasing but now decreasing. So in this particular case, is talking about a video and how many views the video has. So on a particular day, the number of views is 8,192. But then as days pass, those number of views will decrease, so they will go down. And we want to model this with an exponential function. Each one of those decreases 25% each day. So this number here is 25% less than this number. So we know what the percentage is, so we can use kind of the same idea, only that this time we will not be adding the percentage, we will be subtracting because we know the numbers are less and less. So my number here needs to be between 0 and 1, and that's why it's going to be 1 minus r, as opposed to the example we did before, which was 1 plus r. Okay, so once again, so we need to think of the right model in this case, this is called exponential decay because it's going down. Decay is another word for decreasing. So we know the percentage. Again, we will change that into a decimal. 25% is 0.25. So another way to say that it decreases 25% is to say that each number is 75% of the number before. So, when you do it on your calculator 1 minus 0.25, you will get that 0.75. So now that you have the model, now it's about us answering the question. So, in how many days the total will stop being stop being a fan favorite? And notice that, yeah, with less than 1000. So I need to find out when this is less than 1000. So we can set up an equation like this, and we can use a calculator to answer that question. So you can use the table. You can, at this point, you can use Desmos and graph the corresponding and then find the corresponding solution to this. So we can see here that when x equals 8, that is less than 1000. So that's when the video will stop being favored in 8 days. So that's it. So with that, I'm gonna ask you to please um, start doing your practice grade and be ready for questions, the second class of this week, about performance grades basically.